So what is GOLEM and how does it work? And the short answer is that GOLEM is the AI model that has been driving all of Loop54 features, and that is now part of FactFinder. But to tell you how it works and what it does, we first need to go into some background. And traditionally, there have been many approaches to try to solve relevance in e-commerce. And it is a problem well worth solving, because showing the correct product at the right time, it makes a difference between a purchase and a bounce. And simple text matching search engines are not sufficient here. So people have been trying to come up with ways to improve the results of a text search. And some of those are manual rules, conditional popularity learning, and contextual learning, which is what we use in GOLEM. And I'm going to go into a little bit more detail into each of these. So starting with manual rules, which is where an administrator who is knowledgeable of the catalog and of the audience manually decides which products to show. And one way to do this is with visual merchandising. So you would get to drag and drop products to decide which products to show for each query and each page on the e-commerce site. Another one is ranking rules, so that a particular category or brand or keyword is associated with each query. And of course, you can do this non-binary as well by assigning weights to products and product attributes to try to create a balanced result. And this gives the retailer a very fine-grained control of which products show up where. But it's also incredibly time-consuming, and you can realistically only do this for a small part of all the queries. Unfortunately, in our experience, search queries are widely distributed, and tuning the top, say, 1,000 queries only covers a minority of all traffic. And it's also very hard to maintain because language changes and the catalog changes as well. So especially for verticals like fashion and electronics, the entire catalog might change once a year or even more, and you have to start all over again with all the rules and the weighting. So that's why people have tried to come up with a bunch of ways to automate this work. And one very common way is what we like to call conditional popularity learning. And if someone says that they're doing AI in product search, I would say a good bet is that this is what they're doing. And it works like this. So to continue with the kitchenware examples, if a visitor searches for a query, in this case kettle, the algorithm takes note of which product they subsequently click on or purchase. And it would give a small boost to that product the next time someone searches for kettle. And when enough people have done this over time, the results start to converge towards some kind of wisdom of the crowd optimum with the most popular products on top. And the main benefit here is, of course, that it's fully automated and it requires no manual intervention. But there are a lot of downsides, and one is I would say the biggest is that you have a lack of control here. There's no obvious way to blend this with the manual rules. And it's very easy to accidentally destroy the relevance by putting boosts on the wrong products or incorrectly configuring your manual rules, and how this blends together with the automation. Second, it easily gets stuck in a local optimum where the entire first page is filled with products that are relevant enough, and so no one would go to page 2 to find more products, and there might be gems hiding there that will now never get any clicks, so you never collect any data for those products, and it will get stuck in this local optimum. And this in turn means that it would require tons of data, often hundreds or even thousands of interactions for each query before a meaningful conclusion can be drawn. And so each of these small boosts has to be very small, and it will learn very slowly. And thus, again, you get the problem that it doesn't reach very far into the long tail of queries and only optimizes the first few thousand queries, or the most popular queries. Another problem is that there's no way to add products that the text matching engine didn't find or remove products that are not relevant. So all it can do is move them up or down the result list. And since it requires so much data, it cannot reasonably be used for personalization. Unless, of course, you have customers who search for the same query hundreds of times, and that's pretty uncommon. So how do we solve this in a better way? And one of our main goals at Loop54 has been to challenge and try to move away from this tradition of viewing products as separate entities. And we wanted to create a model where interactions the interactions made on a single product can be spread and affect hundreds or thousands of products at the same time. And we think that this is key to having a quick learning and impactful personalization. So how can we create this kind of model? Well, one key insight here is that a problem with a lot of machine learning is that the models rely on pattern matching. And this is very powerful if you have a lot of labeled data, because then you can do supervised learning and converge on a great model in the end. But in e-commerce, we don't really have this data. So we need another approach. And one insight is that humans generally don't need to see thousands of images of a dog to recognize a dog, right? Like many AI models do. Instead, we rely on clustering and categorization rather than pattern matching. So can we do something similar in e-commerce? To solve this, we created an algorithm that clusters products in using a large number of neural networks into a structure that acts as an alternative representation of the product catalog. And when visitors browse and interact, they're not interacting with the individual products of the catalog. Instead, they're interacting with this GOLEM model. And this has the capability to spread behavior to thousands of products on each click or purchase. And I know it's a little bit hand-wavy here with the magic, but unfortunately, my request for a 5-hour slot in this webinar was denied. So we'll have to talk about that later.
Yeah, maybe we can have a magic-only webinar.
I would like that. So what we end up with here is a model that understands these product clusters. And when someone searches for kettle, we would divide the results into context. For instance, here we can see a kitchenware context in red, training equipment in yellow. We have kitchen accessories or like cleaning things in green, and toys in blue. And the size of these contexts can be variable. So we can consider tiny variations in just a brand of kettles, or we can expand it to the whole of kitchenware. And when someone interacts here by clicking or purchasing, the interaction is then spread to all the products in the same context. And that way we can promote all of the kettles after just a few clicks, even if they originally were on page 2 or later. And it's fully automated, but it's also controllable, as Philip has shown already. And we have more features in this vein coming later. But the key difference here is that it's much easier to control this context instead of trying to control the individual products and trying to balance all of these rules. And it only needs a small amount of data, so it can quickly learn new language or slang or changes in the catalog, and it reaches much further into the long tail of the least popular queries. It can also add more products that the text matching engine didn't find, or it can remove products that are not relevant. And since we only need a very small amount of data, we can do it individually per user as well. And both Stephen and Philip has already showed this. And to use this example, if someone first browses on training equipment and then searches for kettle, then we know to show the kettlebells on top instead of the actual kettles. And we talk a lot about search here, or at least I did, but it's important to remember that GOLEM is not a search engine in itself. It's a generalized model for solving relevance in e-commerce. So while we do use it for search, of course, we also use it for category navigation. We use it for recommendations. We can use it for newsletters. We can use it for content search. We can use it to help warehouse employees with picking. We can basically do whatever. We can train it on products. We can train it on user data, content pieces, whatever. There's no end to the possibilities here. And I would say the key takeaway from this part is that GOLEM is a unique innovation, and it's built fully in-house. And the way it models data differs radically from the competition. And that we're just using the tip of the iceberg here of GOLEM, and there will be a lot of more cool stuff to come.